All right, in this lesson, we're going to be doing the very first lesson of our book 1.1.1, and it's interpreting graphs. Looking at that next slide, we have our learning targets. Our first learning target, which is basically the title of the lesson, interpreting graphs. I can interpret a graph. We're going to do one example because that's all they gave us for interpreting graphs in this lesson that we can do remotely. And then the second half of the lesson, we're just going to be reviewing fractions, decimals, and percents. I know I have it when I can discover facts about analyzing a graph. That's the first half of it. And then the second review part is I know I have it when I can convert between all three forms of portions, meaning fractions, decimals, and percents. And then I'm learning this because graphs show up all the time as a way to represent statistics. So a very recent example of how we need to interpret a graph is COVID. So if you were ever wondering about the numbers dealing with coronavirus and you just want to type in COVID information into your browser, one of those first things that pops up is a graph, and you would have to analyze and interpret the data that it gives you and figure out what it's telling you. So just a very recent way to show you how interpreting graphs is important. So looking at our one interpreting graphs example, we need to decide if these statements are true or false. So we have to decide if the new car is more expensive. We have to decide if the slower car is larger, if the larger car is newer, or the cheaper car carries more passengers. Okay, so starting with this. I am going to take my pen, and I'm looking at this first graph down here, and I can see that, that's annoying that it keeps bringing that up. Down below right here, let it delete, is age. And I know that A is farther to the right in age. The farther right we're going on a graph, where our numbers are getting bigger. And if we're talking about a bigger age, we're talking about older. So right now I know that A is older, making B younger. And I don't want to keep marking up these graphs like that because they're pretty small on my screen. So I'm going to decide to keep it organized in a table. So just a different method to keep things organized. I'm going to talk about A in this column, B in the other column. We already so far determined that A is older and that B is the younger car, or newer in more car terms. The other thing that first graph shows us is the cost. And it shows us that A is lower in cost. So I can say money, lower, it's cheaper. That means that B, the younger, the newer car, is more expensive. And so right now that gives me my first question, true or false. The new car is more expensive. The new car, that younger car, is more expensive. So I can say that first statement's true. Now I'm going to get information from my second graph. My second graph shows me, let me have that deleted for a second. Okay, my second graph shows me that the cruising speed of A is more to the left, so it's lower. If it's a lower cruising speed, it's going slower. Oh, that's funny, right? This little box right here looks like it says slower, but it was money sign lower. Slower. And since B is going farther to the right, it means that the cruising speed is higher. If the cruising speed is higher, it's going faster. And then that second piece of information on my y-axis is the size. My size for B is the one that's shorter. It's a smaller size, so B is smaller. A was higher up for the size unit, so A is larger. The slower car is larger. Is that true? A is the slower car and A is also larger. So yep, that's also a true statement. The larger car is newer. The larger car was A and A is the older car. So no, the newer car B is smaller. So We cannot say that's true. And then we're going to go ahead with our last piece of graph data. First thing it tells me about is passenger capacity on the x-axis. B has a lower passenger capacity. That means it can carry less passengers. I'm talking about B is less passengers. I'm going to abbreviate less. A is way farther to the right. It has a bigger amount of passengers, so more capacity for passengers. It can hold more people. And then range of miles. B is lower on that axis, so it has a lower range of miles. A is higher on the range, so it has a higher range. Our last question is, the cheaper car carries more passengers. That cheaper car was A, and it does have more passengers, so we can say that's true. All right, here's our little review over decimals, percents, and fractions now. We can convert between all of them, and that middle piece that we can use is representing these portions as words or pictures. Portions can also be represented in words and pictures. So pictures we can remember, like things like pie charts and so forth. And when we're talking about words, we're talking about things like 4/5, 2/15, so forth. So first thing we're going to go over is converting between decimals and percents. This one I like. I think it's one of the easier ones. If we're switching between decimals and percents, if we have a decimal and we want to make it a percent, decimal to percent means that we multiply it by 100. Multiplying it by 100 just tells you move that decimal spot 2 places to the right. So 0.34 as a percentage now becomes 34%. Same thing, but backwards when we're talking about making a percentage into a decimal. You can think of it either as dividing it by 100 or moving that decimal place 2 spots to the left. 0.786. Pretty straightforward. Here's an example for you to do on your own. You should have gotten 67.5% because we had to move it 2 places to the right. Next thing we're going to be working with is when we have a fraction to a percentage or percentage to a fraction. So first one, fraction to percentage. Sometimes they're really easy to just know in your head. Let's say I gave you 1/2. You might automatically just know, oh, I know that that's 50%. 5/7 isn't always as nice of a fraction to have memorized into decimal form. So I'm going to open up another tab so I have a calculator. We're going to put that fraction, since it's not one that we know in our head, into the calculator. 5 divided by 7. And that just gave me the decimal equivalent. So right now I know 5 divided by 7, 5 over 7, gives me 0.714. I'm just going to round it. The 2 gets chopped off since it's less than 5. But now I have fraction to decimal. I still need to go one step further. I need to take that decimal and I need to make it into the percentage now. And that's the same thing that we just did on the last slide. If I want that decimal to be a percentage, I need to move that decimal spot 2 spots to the right. So I get 71.4%. Next thing that we're going to figure out how to do is how to make a percentage into a fraction. So I have 22%. When we're talking about percentages, we're talking about how much percentage is out of 100. So we can easily make a percentage into a fraction by just placing it over 100 in the denominator. So I can turn this into 22 over 100, since percentages is talking about portions with 100s. And now I need to make sure before I ever circle my final answer as a fraction that it's all the way simplified. So I have 22 and I have 100. What rings a bell in my mind is I know those are both pieces that are divisible by 2. So I'm going to go ahead and divide the top by 2, divide the bottom by 2. 22 divided by 2 in the numerator will give me 11. 100 divided by 2 in the denominator will give me 50. 11 and 50 don't have anything more that you can divide them by. So 11 over 50 is your final answer. Here's one example for you to try out. I want you to take 28% and convert it to a fraction now. You should have started just like we did on that last slide of taking 28 and putting it over 100. And then before you type 28 over 100 in as your answer, you need to make sure that it's simplified. I'm going to start out by dividing both the top and the bottom by 2. That will give me 14 over 50. But I can see that they're still even, so I don't want to type that in as my answer yet. I want to keep simplifying. Divide it by 2. Divide it by 2. Now I have 7 over 25. 7 and 25 have nothing that they're both divisible by. 7/25 is our final answer. Now we have to do decimal and fraction and converting between the two. So decimal I gave 2 examples of on this slide because decimal to fraction I think is a little bit trickier. It has a couple steps. So when you're thinking about decimals, let me just write a random decimal down here. This 1 is in the 10th place. This 3 is in the 100th place. And this 4 is in the 1000th place. Just talking about the place values of those numbers. And we're going to use that piece of information to help us when we're converting it. So right now I have 0.2. I'm going to take this 2 and put it over what place value it was in. So this 2 was in that 10th place, so I have 2 over 10. And I know that 2/10, I can divide that top and bottom by 2. And that will give me 1/5. I'm going to skip F in a second and come back to it just so that we can do the 2 similar examples first. Looking at G right here, I have 2 decimal place values. So I have 0.5 over 2 of them will give me, that was 100th place value, which is the same thing as saying 5 over 100. I know that 5 and 100 are both divisible by 5. So I have a 1 in the numerator and 20 in the denominator. 1/20. You could always double check these answers by typing those fractions into your calculator. So looking at E and double checking, if I typed in 1 divided by 5 in my calculator, I do get that 0.2 back, so we're good. Same thing with G. If I want to type that 1 over 20 in our calculator, I do get that 0.05 back, so we're good again. The only thing that your calculator won't tell you is if it's all the way simplified. So if I typed in 5 over 100, it's going to give me that 0.05, and it didn't give me any indication that I had to simplify it to the 1/20 instead. And then my favorite example, F. I need to take a fraction and turn it into an example. That's just how we were checking our answers. If I have 3/8 and I don't remember in my head what decimal equivalent that is, I can do 3 divided by 8 in my calculator, and that will give me 0.375. Now your turn, I'm going to have you take 0.08 and turn it into a fraction. There's 2 spots right here, the tenths, and then it goes all the way to the hundredths place. So I'm going to take 0.08 and put it over 100. Top and bottom both divisible by 2. Numerator, I get 4. Denominator, I get 50. And again, they're still both divisible by 2. So I can go through it again. Divide top and bottom by 2. Numerator, I get 2. Denominator, I get 25. No longer divisible by anything. And then our last slide of examples is when we are asked for a percentage of a number. So if I want to figure out what 15% of 60 is, let's say, for example, you had 60 pencils and you want to know what 15% of those pencils are, how many there are. 2 steps to complete this. First, you're going to change the percentage to a decimal. So that 15%, I'm going to switch to a decimal, 0.15. I just had to move it over 2 spots to the left. And then I take that decimal and I multiply it by the amount. So I need to take 0.15 and I need to multiply it by 60. And you can use your calculator to do that. 0.15, multiply it by 60, and I get 9. 9 is 15% of 60. And then let's do that one more time. So let's say I have 24%. And I want to figure out what 24% of 800 is. I need to switch that percentage to a decimal. So I need to make it to 0.24 by bringing that decimal spots 2 spots to the left. And I need to multiply 0.24 by 800. 0.24 times 800. 24% of 800 is 192. And that's our final example. Pablo says, good job. Oh, don't walk on that. Sorry.